everyone. In this class 9 chemistry video lesson, we will study briefly about the last two groups of the modern periodic table. These two groups are the halogens, that is group 17, and the noble gases, that is group number 18. So starting with the 17th group elements, the 17th group elements are called halogens. The word halo means salt and gen means forming. And the halogens, when react with metals, they form salts. So that's why these are called halogens. The elements present in the 17th group are fluorine with symbol F, chlorine with symbol Cl, bromine with symbol Br, iodine with symbol I, and astatine with symbol At. All these 17th group elements have 7 valence electrons in their last shell. On moving down the group, the atomic size of the elements goes on increasing due to increase in number of shells present in the elements. The reactivity of the elements down the group decreases because on moving down the group the atomic size increases, due to which the attraction of nucleus for the valence electrons and the incoming electrons decreases. If we talk about the physical state of these halogens, then fluorine and chlorine exist as gases on room temperature, bromine is a liquid, and iodine and astatine are solids at room temperature. Also, all these halogens are colored. Fluorine is yellow colored gas, chlorine is green colored gas, bromine is red colored liquid, iodine is violet colored solid, and astatine is black colored solid. Being non-metals, they don't have any free electrons for carrying the charge, so that's why they are bad conductors of heat and electricity. Then they are having 7 electrons in their last shell, so it means they can gain 1 electron readily to complete their octet or to acquire the nearest noble gas configuration. So that's why all these halogens are electronegative in nature. Then their boiling and melting point increases with increasing atomic number, means down the group their boiling and melting point increases. Then we have the chemical properties of halogens. As it is already discussed that the reactivity of halogens decreases down the group due to increase in the size of the atoms. So that's why if potassium iodide reacts with chlorine being more reactive than iodine, it will displace iodine and it will form potassium chloride along with the formation of iodine. Also, if potassium iodide reacts with bromine being more reactive than iodine, it will displace iodine from potassium iodide and form potassium bromide along with the formation of iodine. So the order of reactivity that is given here is it decreases from fluorine to chlorine to bromine and iodine. Means fluorine is the most reactive element in this group and iodine is the least reactive here. Then all the halogens possess oxidizing property. Means halogens are good oxidizing agents and this oxidizing property decreases down the group. When any halogen reacts with any other element or compound, these halogens gain electrons from that element or compound to oxidize them. So that's how they act as oxidizing agents. When the halogens react with hydrogen, they form hydrides. For example, chlorine reacts with hydrogen to form hydrogen chloride. And these hydrides are the covalent compounds. And when these hydrides dissolve in water, they form the acids. For example, when hydrogen chloride is dissolved in water, it forms hydrochloric acid. Similarly, when bromine reacts with hydrogen, it will form hydrogen bromide. And when the hydrogen bromide will dissolve in water, it will form hydrobromic acid. The next chemical property is the ionic compound formation. Whenever the halogens react with the metals, they form the ionic compounds. Because the metals are electropositive and halogens are electronegative, so that's why the metals lose electrons which are gained by the halogens, and due to the presence of opposite charges on them, they combine to form the ionic compound. So like sodium reacts with the chlorine to form sodium chloride, which is ionic compound. Similarly, calcium, magnesium and zinc, they react with the halogens to form the ionic compounds. Then afterwards, next one is the covalent compound formation. When the halogens react with non-metals, they form covalent compounds. Halogens react with metals to form ionic compounds and they react with the non-metals to form covalent compounds. For example, here phosphorus is the non-metal which reacts with the halogen, that is chlorine, to form phosphorus pentachloride, which is a covalent compound. Similarly, sulfur, which is a non-metal, it reacts with chlorine to form sulfur monochloride, which is a covalent compound. Here one more thing is given to you, that all the halogens are colored as we have studied earlier. But when they react with the alkali metals, means when they react with the first group elements, they form the corresponding halides. Means when lithium reacts with chlorine, it forms lithium chloride. When sodium reacts with chlorine, it forms sodium chloride. And similarly, when other alkali metals react with the halogens, they form their respective halides. And these halides are white in color, and all these halides are soluble in water. Then next one we have the 0 group or 18th group elements. 18th group elements are helium with symbol He, neon with symbol Ne, argon with symbol Ar, krypton with symbol Kr, xenon with symbol Xe, radon with symbol Rn. All these elements are called as the noble gases or inert gases because they are the least reactive elements in the periodic table because they have the most stable electronic configuration. In this group, all the elements have 8 electrons in their valence shell except helium. Helium has 2 electrons in its valence shell. The size of these elements also goes on increasing down the group due to increase in the number of shells. The 18th or 0 group elements do not react under normal or ordinary conditions, but under special conditions they can also react to form coordinate compounds or the complex compounds. For example, xenon can react with fluorine to form xenon hexafluoride or xenon tetrafluoride, and some more other compounds of these noble gases are known to us.